Okay, question 10 of chapter 8, mixed exercises. So we've got an expansion that needs doing, 3 plus 10x to the power 4, and we just need to expand that fully. So let's look at what Pascal's triangle is. If you start with 1, the next line is 1 and 1. The next line is 1, add 1 and 1, 2, 1 and 0. 1, 1 and 2 is 3, 1 and 2, 2 and 1 is 3, and 1. And then 1, 1 and 3 is 4, 3 and 3 is 6, 4, 1. Okay, now that should be enough for this expansion. Okay, and these values here of 1, 4, 6, 4, 1 is the values of the NCR. Okay, so if we did 4NC3, we end up with 4. If we do NC4NC2, 4NCR2, we get the 6. Okay, so it's just coming down here. So what do we have here? We have the expansion, which is going to be 3 to the power 4, okay, and it's going to be multiplied by the binomial expansion of 1, and it's going to be multiplied by that 10x to the power of 0. Then we're going to have 4 from the next line of the binomial expansion, just over here, okay, and it's going to be times 3 to the power 3, and it's going to be 10x to the power 1, and then 6, 3 to the power 2, 10x to the power 2, then we're going to have 4, 3 to the power 1, and 10x to the power 3, and then finally we're going to have 1, 3 to the power 0, and 10x to the power 4. Okay, and that's what binomial expansion is going to be in its simplest form. Okay, which makes it a lot easier to remember when you have it set out like that. That's 1, 3 to the power 4 is 81. Okay, 3 to the power 3 is 27, times 4, 108, times 10, 1080, x. Okay, 3 squared is 9, times 6 is 54, times 100, because that's 10 squared, 5400 x squared, and 3 times 4 is 12, times 10 times 10 times 10, which is 1,000, so we get 12,000 x cubed, and then finally this is 1, and this is 10 to the power 4, 1, 2, 3, 4, x to the 4. How did they want this? Use binomials to expand, given each coefficient as an integer. Okay, so basically 3 plus 10x to the 4 is equal to 81 plus 1080x plus 5400 x squared plus 12,000 x cubed plus 4 of them, yeah, x to the 4, 10,000 x to the 4. Okay, part B. Use your expansion with the appropriate value of x to find the exact value of 1003. So they want us to do 1003 to the power 4. So if we say that is equal to the 3 plus 10x to the power 4, We can take the 4th root through both of them. Get the 1003 is equal to 3 plus 10x, meaning 1000 is equal to 10x, and 100 is equal to x. Okay, so there's our value of x. Putting it into this up here, we end up with 81 plus 1080 times 100 plus 5400 times 100 plus 12,000 even times 100 plus 1, 2, 3 times 100. When I've been saying 100, I mean 100 squared, 100 cubed, etc. Okay. And then quickly putting it all into the calculator. Okay. It's 100. Okay. That's a rather large number. So, 1, 2, let's have a look. 1, 2, 3, 4. Times by that, so 1, 2, 2, 3, 4. Okay. 2. Okay. And 81. So a nice exact value of that is, I don't even know what this number is, 502101. So it's a UK billion, 12,054,108,081. Okay. Now, interestingly, if you did that on your calculator, you would be missing the 1 on the end of it, so they would know if you've done it on your calculator. Okay. Right then. Question 11. Let's get set up for question 11. Question 11. Expand 1 plus 2x to the power 12. In ascending powers up to x to the 3. Okay, so because the Pascal triangle is quite easy to do, we could do that until we had 12 lines of it. But of course, that's going to be down here. And at that point, it becomes quite ridiculous, which is why we've got the NCR formula on it. So let's just quickly get that out in terms of the 0, 12 to the 0, 12 to the 1, 12 to the 2, 12 to the 3. So that's the x squared, and x cubed terms there. Okay. And then they're going to be times 1 to the power of 12, 1 to the power of 11, 1 to the power of 10, 1 to the power of 9. And then we have times 2x to the power of 0, 2x to the power of 1, 2x to the power squared, 2x cubed. Okay, so that whole thing is 1. Okay, so 12C1 is 12. 12C2 is 66. And 12C3 is 220. I'm not going to write in the times 1 for each one because 1 to the power of 9 is still 1. Okay, and then we have the 2x, which is just the 1, times 2x, so that equals 24x. This is going to be times the 4x squared. 66 times 4 is 264 x squared, and then 2 times 2 times 2 is 8x cubed. 220 times 8, 1760. X cubed. Okay, question 11. Part B. By substituting a value in for x, find an approximate value, which must be stated in the answer to part A. Calculate an approximate value to 1.02 to the power 12 is going to equal. Now then, this is where we end up with 1 plus 2x to the power 12, and so we end up with 1.02 equals 1 plus 2x. 0.02, 0.01 equals x. Okay, just solving that out. So now that we've got that, we can quickly substitute it in here to the equation that we just did in part A. So we are going to have 1 plus 24 times 0.01 plus 264 times 0.01 squared plus 1760 times 0.01 cubed. Okay, and so when we put that all in, times 0.01 to the power 3, okay, we get 1.26816. There we go. Question B. Right. Use your calculator, write down all the digits in your display to find a more exact value of 1.02. Okay, so for C, 1.02 to the power 12, using the calculator, 1.02 to the power 12 is 1.268241795. Okay, and then finally, part D. Okay, calculate to 3 sig figures the percentage error of the approximation found in part B. So, since we've got a smaller number here, let's do the 1.268241795 and take away the 1.26816. Okay, do a takeaway on that. Take away 1.26816. Okay, and it gives us, what's that, to the minus 5? So 0. 1, 2, 3, 4, 4 zeros. 1, 2, 3, 4, 8. 0.794, 5 even. Okay, there's some rounding going on there with the calculators. Okay. Now, that's the bit that's correct. We're looking for the percentage error, the approximate percentage error of the approximation found. So that's what the error is, and that's what it should have been. So it's what percentage of this is this. So very simply, we're going to divide that by 1.02 to the 12 and multiply it by 100. Divided by 1.02 to the 12, which is very small, times by 100, gives me 6.4494 times 10 to the minus 3, so 6.45 times 10 to the minus 3% to 3 significant figures. Very good. Okay, question 12. Is very simply x minus 1 over x to the power of 5. Let's have a look at that Pascal triangle again. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and now 1, 5, 10, 10, 5, 1. Okay, so expanding this out, we're going to have 1, 5, 10, 10, 5, 1. We're going to have all of that times x to the power 1, x to the power 2, no, x to the power 5, sorry, x to the power 4, x to the power 3, 2, 1, and 0. And then we're going to have a minus 1 over x. And finally, 1 over x. And that's going to be to the power 5, 4, 3, 2, 1, and 0. Okay, so that gives us x to the power 5, x to the power 4, 5x to the power 4 minus 5x to the power 4 as a minus divided by the x, okay, which gives us minus 5x to the 3. This is going to be a 10x. The cube, the squared, leaves us just an x equals a minus 10. The x squared's on the top go, but it leaves us an x on the bottom. Positive on this one, 5 over x squared. X on top, yeah, no, x cubed, 5 over x cubed. Would this one not be x squared? No. Okay, and then this being 1, 1, 1, so minus 1 over x to the 5. Alright, so we end up with, finally, x to the 5 minus 5x cubed plus 10x minus 10 over x plus 5x cubed minus 1 over x to the 5. I don't think that cancels particularly much more. You could do things where you take the x to the 5 out, but